you see a problem right off the bat that we might need to deal with?
Negative.
The negative, right?
Yeah.
Look out for a GCF.
You just take
Is
off-
anything shared? No.
No.
If the first term is negative, that thing is impaired. Ooh, I can't deal with it if there's a negative in front. What's the very first thing that we should do before tackling this trinomial?
Take out all
This should be
Take out the negative. Can't take out a number, can't take out a variable from everything, but take out the negative. So what happens to my negative 5k squared? It is now a positive 5k squared, but be careful, I took out a negative from everyone. So what happens to the 22k? How about the 15? Good. It flips the signs of everything inside. Okay? Now, for you guys from yesterday, off to the side, do you remember whose factors I'm looking at? The grouping method, remember it's the big method. Yeah. Multiply the first and the last. Multiply the first and the last. So it's going to be factors of 5k squared times 15. And if you guys multiply that out, any mental mathers out there? Oh, not quite that big. 75. Only the k is squared, not the 5. Does that make sense? Only the k is squared, not the 5. So we look at the first and the last, 75k squared. Now, how can we get that? The last sign is negative, right guys?
Yeah.
So we know that we need to do opposite signs in the sense of the signs must change. So we're going to do one positive and one negative. But let's just start thinking about our factors. If we have 1k and 75k, can those subtract whether the negative is here or whether the negative is here?
No.
That's not going to make what we're looking for, which is 22, right? So let's keep going. What else goes into 75? 5k goes in. How many times? 15. But this 5 and 15, can that add or subtract to be 22? Okay, we gotta keep going. 6 goes in, no, 7 goes in, no, 8 goes in, no, 9 goes in.
Nope.
3 goes in. Hey, we missed one. How many times does 3 go in? I think 3/4 is 75 cents, right? Why is this a good one? Okay, now, if I add it, I'm in trouble, right? But if I subtract it, oh, that's right, the last sign is negative, the signs they must change. The question is, who needs the positive, the bigger or the smaller number?
The bigger.
So the bigger needs the positive, the smaller will have a negative. Now, for those of you that are trying to understand this method, we need to take these two and do what with them? Not subtract, leave it alone. This is that new factoring by grouping method. We can split 22k up, and we can write negative 3k with a plus and a 25k. And then what do we do with the other terms?
Bring them down.
Bring them down. Now do we have that little negative is still chilling? Oh, thank you. Now we have 4 terms. And the answer is? Yeah. So what are we going to do with those 4 terms? Group. So we can group the first 2 and see if it works. Group the last 2. We can rearrange if we need to. Group the first, group the last. Question, is anything shared in the first group?
Okay.
Yep, so let's pull it out. Pull it out. What's the snazzy math term for pulling it out? Factor. Good. Pull out the k. You get 5k minus 3. Plus, is anything shared in the second pair?
5.
Good. Pull it out, aka factor. When you factor, you divide away, right?
Right.
So, exactly. I need to think.
Where'd you get home?
25k is 5 times 5k. Take away one of the 5s. There's only a 5k left. 15 is 3 times 5. Take away the 5. What's left?
3. Wait, why didn't you? Same. Fine.
Yeah, you can double check, right? 25 and 15. Good. Now we can say, hey, is there anything in common? And the answer is, aren't those the same?
Yep.
So what are we going to do with that? We're going to pull it out, right? When we pull away the green from everything, there's technically still that weird little negative shown. What's going to be left when you take away the green? Okay, and the plus and the 5. and a plus in the 5. Then we
Why-
say, hey, who is underneath all that green?
I don't know.
The 5k minus 3 was underneath there. So what are we going to put as our answer? 5k minus 3.
Wow. That's pretty hard.
Now, the table should have gotten you to the same place. The only thing the table might have done a little differently is that there wouldn't be extra parentheses. And yeah, there's a lot going on with the table in this one. We have big numbers. We have 15, we have 5. There's lots of arrangements. But question at the end, we end up with the signs they must change?
Yes.
Yeah. If we were to FOIL this, which on your test, if there's a factoring problem and you want to see if your factors are correct, can you FOIL the check? We would have 5k squared for the first. For the outer, we would have 25k with a positive, the inner 3k with a negative. The last, we would have 15 with a negative. There's a negative chilling outside of anybody, or I should say everybody. This one ends up to be 22k. When we bring in the negative, that'll be negative, this will be positive, and the 5k will be negative. Does this match our original problem? And the answer is
That's a lot.
C.
It is a lot. It's a hard problem.
There's so much going on in this.
It's a hard problem. The nice thing is on tomorrow's test, you know what? Friday. Friday, look at the board. Yeah, Friday. Wait, pause. On Friday's test, you know the problems with the number in front? I bet there's going to be 2, maybe 3. 2, maybe 3. Up with the number in front.
Oh,
Otherwise, maybe there's going to be the ones with the x squares in the front, which are easier, right? Maybe there's going to be like difference of squares ones where we have like a shortcut to get there. There's not going to be a lot. 20 or less. More than 20, which means they're like, yeah, well, we have to be careful. But wait, have I shown you how to show work on these problems? Yes. And do I grade partial credit? Do I give half points, things like that?
Yeah.
So you just need to show everything you can and do the best you can, right? Now we need to get some things worked out. And one of the things we need to get worked out is section 7.8 to end. Okay? 7.8 to end. Now, the nice thing is about 7.8 to end of the chapter, it basically says, let's review all the factoring stuff we've done. Now, normally I have you write word for word, right? But not now. Not now. I do want you guys to write factoring completely, because this is what you're going to see in directions for a problem. And I do want you to write what to think through, but I'm going to go ahead and highlight some stuff to shorten it. Is that okay? Only what I highlight do you need to write down. What to think through. Don't even worry about guidelines and all that stuff. Just get to number 1. What to think through. Number 1. Factor out. And guys, what's an easier way of saying the greatest common monomial factor?
GCF.
Yeah, let's just say GCF. Technically we said GCMF, but that's alright. Let's just say GCF. Factor out the GCF. Is that okay? Just shortening it. Number 1. Factor out the GCF. If there is one, maybe there's not. And what was my way of remembering that? Look out for the GCF. Look out for a GCF. Is anything shared? Look out for the GCF. Is anything shared? Right? And part of that is if the first term is negative, that thing is impaired. Get the negative out also. So factor out anything shared. Factor out a negative if it's in the very front. Number 2 says, look to see if there's one of those special problems. Look to see if there's one of those special problems. A difference of 2 squares. You can technically put a perfect square trinomial, but I think we kind of learned. If there's a perfect square, we're going to see if we can square root and use those numbers, and sometimes you can, and sometimes you can't. We're not going to really memorize a formula for that, but difference of 2 squares is very important to make sure we understand. Number 1, factor out the GCF. And a negative. Number 2, look out for a difference of 2 squares. Does it have only 2 numbers? Hey, what do you guys see in the example we're about to look at? Yeah, that's a difference of 2 squares. That looks weird. Hold on, wait. Number 3. Number 3. Factor a trinomial. Factor a trinomial, and I'm going to go ahead and put with a table or grouping. Now, some of you I know have gotten really good at factoring. during this homework. So maybe you can do some of these factorings without a table. But the majority of us need to show some work. The majority of us need to show some work, right? Barry, this is the exact same thing we were just doing, I think, right? You're answering using an answer here using someone else's or something else's work. Come on, that's not how you do homework. Number 4. You talked to any class about this. Number 4. It says, hey, what if there are 4 terms? What do we do with 4 terms? Grouping. I'm going to have you write that whole one down. If it's a trinomial, use a table. Or that nifty grouping that we saw barely yesterday and today. Yeah, number 3, factor a trinomial with the table or the grouping that we saw just yesterday or today. Number 4, though, if there are 4 terms, let's just try pairing up, let's just try grouping. No table. No table. Okay, now we have a problem at the very bottom. Now guys, I don't know about you, but does any of this sound new per se? Not really. Maybe they're just putting it together in like bigger, harder, or at least just longer problems. Now not longer in the sense of worse from a table, but longer in the sense of maybe you have to do this and this, or this and that, or this and that. Maybe you have to do 2 and not just 1, but that's all. That's all that's new. And basically we're going to be able to review factoring today.
So for that, is it all the whole chapter? That's
Well,
everything.
careful. The whole chapter since your quiz. Does that make sense? Like before factoring, what were we doing? We were counting terms and seeing binomials, trinomials, monomials. We were putting things in standard form, descending order. We were looking for degrees and leading coefficients. We were adding and subtracting polynomials with combining like terms. So there is that first half, which is why I want you guys doing those corrections so that you're reviewing and thinking about those before we work on the chapter review tomorrow, which is the whole chapter. But this is a nice summary of like all 7.5, 7.6, 7.7, 7.8, which is half the chapter. Factoring was half the chapter. Okay, let's look at this problem real fast. Okay? There's a whole table. I know, you wrote it down. Big summary. Let's just look at it. The very first thing you should think whenever you see the word factor is look out for the GCF. Is anything sure? Well, is anything sure?
Yeah.
Oh. Okay, a 4 is shared in what else? A to the power of 2, or a squared. Now factoring, you always need parentheses, right? For a squared, we are factoring out. If you need to, you can think of 36 a to the 4th as 4 times 9 times a squared. Well, you could do a squared if you want to be super snazzy. Or you could just be a little bit less snazzy and just say a times a times a times a times a. 4a squared is going to be 4 times a times a. So we're going to take out those and take out that. My question is, what is left?
4a squared minus 1.
Remember, you don't put a 0 if nothing's left. You put a 1. Times 0, everything goes away. We're in trouble. Times 1, oh, we're good. Now, have we done one thing? And the answer is yes. Are we done? The answer is no. This is a problem that needs 2 steps. First, look out for the GCF. Is anything shared? Yes. Okay, pull it out. Watch. Now we have to ask, can we keep going?
Yeah.
4a squared is done. He's chilling. My question is, does this look like anything special?
No.
It's not a trinomial. It doesn't have 4 terms, but it is a difference of 2 perfect squares. Wait. Difference of 2 perfect squares. Question, how can we factor those differences of 2 perfect squares? We ask ourselves, who is squared? You guys see how 3a is what's being squared for 9a squared? What's the square root of 9?
3.
What's the square root of a squared? So we can take that. Now you don't necessarily need to write that step, but it's good to think through. If the last term is negative, the signs, they must change. Yeah, take that 3a squared and say, oh, it's a 3a and a 3a. And what do I do with this one? It's a 1 and a 1. Whew, that one had 2 steps. Look up for the GCF. Is anything shared? Fold it out. Wait, there's a difference of squares. Keep going. So factoring completely says, do what you can at the beginning, and then after that, if you can keep going, do so. Good.
What if I used a square minus b squared on like the 36 one?
Well, here's the dilemma. You would have something that would technically be equivalent, the same, but here's the problem. This is actually the same as that, and this is the same as yours, but yours you haven't gone far enough, because after you do that, when you have 6 and when you have 2, you can pull the 2 out after that. Does that make sense? So you can do that, Barry. Just take out the 2 from both, which will leave you with a 4 on the outside. Yeah. Josh.
Oh, could I use the rest method on this problem?
Actually, why don't you do so right now, because we're about to use this slide. Alan, do you have a question?
I need lead. I need lead. I don't have any.
Oh, no lead. Kaylee's got you. She didn't get that. Okay.
So,
7.
exercise.
There's on that. I'll try 7. Yeah. Thank you.
Well, what this says when you see factoring completely, and I just crossed it out instead of highlighting it. When you see factoring completely, you might be able to do one step, and then there might be another step to still keep doing.
Yeah.
Does that make sense?
Yeah, but like how you function for steps.
Well, one problem won't have all 4, and here's the reason why. 1 says look for GCF. 2 says difference of 2 squares is a binomial. This one says what if a trinomial. And this one says what if 4 terms. So different cases, different possibilities.
That before every work
Right.
is
And then depending on what you have, maybe difference of 2 squares, maybe table, maybe grouping. Does that make sense? Yeah, it depends.
Are they going
On Friday. Could be, but we still got a review tomorrow to keep on practicing. Now, kiddos, here's something very important for us for the entire second half of chapter 7 to get straight. The difference between factoring and solving. If I were you, I would actually put stars by both of those words, because this is about, can you read the directions? Some of you in your quizzes, when you go to correct, when you read the word factor, when you read the word solve, in those quizzes, you might have read the directions and not even known what it was asking to do. But what I say when I read that is, but you saw it in homework, and you're going to see the same directions in the review, and you're going to see the same directions on the test. So make sure you're paying attention to the words. Factoring. I'm just going to give a couple hints. Factoring. Use parentheses. I can spell parentheses. Is it E or an A? Why is this looking weird to me right now? Yeah, right? Parenthesis would be a singular, parentheses is plural. Use parentheses. There's like plural and singular. Use parentheses. What do I mean by that? What we are doing, what Diego was saying, we're looking for GCF, looking for differences of squares, looking for factoring trinomials or grouping. Solving, do you guys see what's new in solving? Okay, skip some lines because we're going to solve examples. I would say maybe skip 2, maybe 3. Skip lines. But look at the differences between factoring and solving. Now, question. In the first factoring problem, is there anything shared? Okay, go for it. Factor out the GCF. Start there. The first example, factor out the GCF if you haven't yet already. And ask yourself the question, what is left? Can I factor that also?
Yeah.
Good. Factor out the GCF. And ask yourself the question, what is left? Can I factor that also?
Wait, what are we trying to do? We do positive on the outside or negative?
Well, I see the last term is negative, so the signs they must change.
So they positive?
But hold on, before we do that though, what did you guys factor out that was in common? Good. Did you guys get m squared minus 2m minus 8 as what was left?
Yeah.
Okay, good.
No.
Oh, double check. Does it make sense?
Oh.
There was only one m that was shared, so I took away 1 from him, just the 8's left, took away 1 from that,
I just take away
and took away 1 from that. Does that make sense?
the exponent leaves or
Sorry.
Oh, the exponent doesn't leave. Remember with m cubed, that 3 just means there are 3 of them, so when I take away 1, there's still m squared left.
Oh, okay.
Does that make sense?
Yeah.
Yeah. Okay, hold on, coming back.
So if it was just like m squared, I like that.
Yeah. M squared, m and m, and then 1 goes away. I said look at what's left and ask yourself the question, can you factor that? Can I factor a trinomial? And the answer should be yes. The answer should be yes. Now we can use a table off to the side if you want and think factors of negative 8 and thinking of their sum, right? What signs can you fill into your parentheses? If the last sign is negative, the signs they must.
Negative 4.
And some of you have already figured out, hey, look at 4 and 2 specifically. Good question. What sign does the bigger one need to have?
Negative.
Negative. So I'm going to put a negative 4, a positive 2, and what variables go in the front of those? What's missing in these blanks?
M.
Good, because of m squared, right? What would happen if you guys multiply sorry, I should say 4. What happens if you multiply and distribute? What are you going to get? Yep, and then times m, you'll get m cubed minus 2m squared minus 8m, right? Good, that's okay. Josh, we've only done one example, so you can look at him as we go on to the next one, okay? Alright,
After the last problem, because I want to see it.
so solve. Solve. We did one factoring problem. Guys, do you see any equals 0 in any of this just factoring problem?
No.
No! But what do you see as soon as you look at this problem? An equals 0. And what's the word that's going to be in the directions? Solve. Now here's the struggle. I can't split up until I, so it's factoring plus. It's factoring plus. It's a two-sided problem. There are 2 things to do. Factoring plus. We are going to use the equals 0. We are going to split up, but we cannot do the solving part until we do the factoring part. So I want you guys to look on this side. We're going to get to the equals 0 in a second. Ignore him for right now. We're going to get to the equals 0 in just 1 second. We're going to ignore him for right now. Let's see if this catches up. It's being slow right now. There we go. So just look on the left-hand side. Is there anything in common? C. Let's pull that C up. Do you guys see a C squared? C is C squared, that's silly. Minus 7C plus 12 left over after we factor out the C.
squared.
So keep on writing equals 0. But I saw the common C. Pulled him away, 12 was left. Pulled him away, there was still 1 C left. Pulled him away, there was still C times C, or C squared left.
So why do you take C?
Because he's in common. Factor out the GCF. Factor out
I
anyone in
wanted to see
common.
on the never mind.
He's the one that we pulled away. A. Well, we can only take what's shared, and so if I was to think about the C cubed and the 7C squared, actually negative 7, and the 12C, if I was trying to think of what's shared, C cubed only has in common with the rest. So I can only pull out what's in common. So I pull all of
You
those
forgot to
away.
put-
I
wait.
pull out 1C
No.
from each. And what's left? Does that
So
make sense?
if there was 12c squared, then the 7c where can we see it all?
Then we could pull out a c squared. Yeah.
Oh, this
Now,
is
wait,
if
wait,
it's
wait.
equal to
We're
0.
not quite done. We're still gonna do the equals 0 part, but the question is, in these big problems, these big Mama Bahama problems, we pulled out a C. Question: can we keep factoring?
Yes.
The answer is yes.
Oh.
Do you see it? Still say you see a lot. I apologize.
Sure you
You observe it?
We gotta see it.
I see it.
The last sign is positive. The signs are the
Same.
same.
Yeah.
And what are those same signs? Yeah, look at the middle. Don't I have to have some negatives? Okay. Can you guys tell, since there's no number in front, can't we just do C and C?
Yeah.
Can you use 12 is 1 and 12, 2 and 6, 3 and 4 sounds great. Without even doing a table, look, we can work this thing.
I'm overthinking this.
I know, I am too. It's just because it equals to 0.
And you guys are used to those crazy ones with the number in front, remember?
Oh, jeez.
Those are beasts. But this one,
Beast.
because we didn't show the table, Jackson, but you can think factors of positive 12.
Would that be your final answer? Would you leave the 0 there?
Negative 1 and negative 12 aren't good.
Oh.
Negative 2 and negative 6 aren't good. But negative 3 and negative 4 sum to be negative 7. That's my winner win.
Would that be final answer?
Ooh, no, but we've done a great job factoring. Oh, wait, we've done a great job factoring. What's the second half?
You put everything
Yeah, I think that's
Good. Take each. Now, careful. Wait. We have to take 3 things. We have to take each piece, and set equal to 0. Each piece, take the C equal to 0, take the C minus 3 equal to 0, take the C minus 4 equal to 0.
So you have to do that?
That is what solving means.
So if we put
Factor.
we wrong.
You would be happy.
C equals
But you
0,
wouldn't
C
have
equals 3,
finished
C
the
equals
problem.
4.
Wow.
That's why I'm teaching you the difference
It's not
between
that
solving and factoring. But actually, guys, in the quiz, I wouldn't get more than probably one of these factor and solve.
There was only one of those problems on
And in the quiz, it was already factored for you, said solve. You just had to know to split up. So you might see one of each. We need to finish. There'd be 3 answers. Do you see it?
Yeah.
Diego, let me finish solving this last one just real quick. Do you see 3 answers?
Yes.
So if I had an answer blank, some of you got confused on this on the quiz. If I had an answer blank, what would you write if I said C equals, Rob? If I had one, commas.
C equals 3 and C equals 4.
0, 3, 4, It's one answer, but how many pieces are there to it?
3.
Why? How many factors were there?
3.
How do I know to do this whole equal 0 thing? It has a
0.
0, right?
If you put C equals, that's still okay.
So whenever
Yeah, you can say C equals 0, C equals 3, C equals 4, Caleb.
so whenever there's like enough factors, how many factors there are?
That's how many answers you should have, unless if I had C minus 3 and C minus 3, it had the same answer, and we usually would just write it once, not twice. Now, Diego, let me get to one more example real fast, okay? These ones are factoring. I think we're better on factoring than we are on solving. Can you do a solving example? In the review tomorrow we will. Kiddos, let's actually just look at, which one looks more confusing, A or B?
B.
It looks more confusing, but
Well, let's do A just because it looks longer. Is that okay? Question. Do you see anything in common? Wait. Read the directions. Read the directions. It says to solve. And I see an equals 0, so don't stop after factoring. But, example. Do I have anything in common? Look out for the GCF. Is anything shared? Yes. W is shared. So I have W squared minus 8W plus 16 equals 0. Can I factor further?
Yes.
Yeah.
It's the same number.
So look at my trinomial.
Like on, like.
The last sign is positive, the signs stay the same, but you see why it's minus and minus? Okay, Diego, thank you for knowing it, just don't say it anymore. What are my two variables? W and W. And Diego's been saying 4 and 4, do you guys agree?
Yes.
Does -4, -4 times -4 equal 16? Yes. Does -4 plus -4 equal -8?
I need help.
And then equals 0.
2.
Good, split it up.
Oh yeah. W equals 0, W equals 4, W equals 4.
Now, here's the case actually, Caleb, you were asking
Yeah.
about.
It's just one, it's just W.
Exactly. So W equals 0 is great. W equals after some algebraic addition 4. After some algebraic addition 4. But what would we say as our final in the blank answer? Just 0 and 4. Just 0 and 4. Now, Josh, go ahead and ask your question.
No, I was just gonna say the answer.
Oh, for the next one?
No, for
Oh.
the
Can I show you guys something real quick that you might see in homework? Remember, you're doing odds, so you can check your answer. But guys, what if the question looked differently? Hold on, focus. I want to show you something tricky. What if the question looked like this instead?
Oh, you can just subtract 25x.
I see an equals, but I don't see a 0, and I'm
Subtract
supposed to see a 0.
25x.
Use your algebra to
And then it'll be
get
equal
a
to
0. So if they show it to you all weird and rearranged, you're okay because you can use algebra.
X cubed minus 25x equals 0.
You can move things to other sides of the equation. Then, do you guys see how now we're going to factor?
Yeah.
Now it looks normal, right?
Yeah.
Before it didn't. So when you see the directions solved, when you see an equal sign, you need an equal 0, and if they give it to you mixed up, what are you going to do?
Make a 0.
Get it, get it to be 0. Don't make it. That means you're like randomly creating from nowhere. Only God can do that. Okay, ready? Take a picture. Why am I giving you odds? So you can check and come back tomorrow to ask questions. Last night you were supposed to work on quiz corrections. Now guys, listen. Quiz corrections are due tomorrow as a homework assignment, but you can turn it in